What is this beautiful starfish? That is the starfish. that makes sense. What did you say?
It's a confirmation.
That is a pattern. And scientists generally don't really understand why the starfish is shaped like this. It just is. So there's mysterious patterns, and there's patterns that we understand a little bit better. We're mostly going to cover the patterns that we understand. These patterns can be used as part of your design. And so think of these patterns in terms of using them in a design. We're going over their usefulness and what they do in a natural system, because they all perform various functions. So branching patterns are extremely common. They're all over the place, and they're used to gather or distribute energy. So this, you're distributing energy here, releasing it from the clouds. Here, you're gathering it and then distributing it into the ocean. So this is a fractal pattern, which is a form of branching, and there's many, many fractals in nature. There's a lot of mathematical patterns are found all over nature. There's certain types of mathematical patterns that are ubiquitous. So tree limbs are actually, do actually follow a lot of fractal geometry. It's very interesting. You can feel it when you're looking at a tree limb. There's a symmetry, even though there's nothing symmetrical about this. There's something that's have you ever felt that?
It's like a balance. It's like what?
Like a balance.
A balance, yes.
Yes, a balance.
A balance, yeah.
Okay, so watershed is a very common branching pattern, and this is something you should know where your watershed is in your design, but you can also think in terms of watershed in your design, even in your yard. How are you going to distribute the water energy throughout your system? And this knowledge has completely changed how I design a garden. A lot of times my gardens will look like a watershed with meanders and bringing the water into the system and distributing it throughout the system. There's examples of watersheds and different types of the mountains also have this branching pattern where you have the ridge and then you have little mountains coming out. Another type of branch looks like a tree, yeah. Isn't it amazing? So with a tree, you have a distribution and a gathering. The tree goes both ways, takes nutrients both ways. More patterns. Okay, this is another pattern, streamlines or meanders. It's distribution of sediments and nutrients. A meander slows down the flow, so you have a canal that's straight. You get floodwaters just rushing down there. And if you have a meander, it will slow it down enough around the curve so that some of the nutrients and sediment drop on the curve, which is important because otherwise it just all goes out to the ocean. So you're keeping some of your nutrients in the system when you put a meander in. One of the chief ways of building up a waterway that's where there's a lot of erosion is there's different techniques for creating a meander. So you have this eroded pathway that's just going straight down the mountain. You'll force it to curve. That's a specific water revitalization technique that permaculturists use. With an increased edge, so when you force a stream to curve, it's covering more territory. You have more land that's being covered by the stream, you have more edge. Things grow on the edge. You have the riparian area on the edge. To move nutrients through the system and allows them to actually arrive in the system. Here's an example. And it's interesting that these curves, there's a physics to them, where when they go around the curve, they actually do drop sediment, and the physics of it will cause the curve to increase. So all you have to do is put just a little curve in there and it will continue to increase and push out into your system. So there's an example of,
And the blue lines are the what's called the continental divide. The blue lines are what's called the continental divides.
yeah, these are, this is a branching pattern and the meanders. You can see that's the biggest waterway system that we have in this country.
But his question is, the blue line that makes the western edge of that is the continental divide. It means that a raindrop that falls to the east of that will end up in the
Yeah,
Mississippi,
right.
and a raindrop that falls on the west of that blue line will end up in the Pacific.
Yes,
And
that is a
the
continental
ones that are
divide.
in the Mississippi obviously end up in the Gulf of Mexico.
I think it is.
Yeah.
That would make sense. Yeah.
Thank you.
You can answer that question, because I don't know.
Well,
It's a good point.
I've been traveling a lot, and I've passed 2 or 3 times through a place where there is a sign continental divide. So we searched a little bit what it was, and that's what
It's the
you
water.
said.
It's the watershed.
It's the
And
watershed.
then I saw those two blue lines, and I recognized those from North Carolina, which is a place we have spotted. And so I thought, hey,
Yeah, that's
What's
interesting.
your-
I didn't know it went so far over into Idaho. That's,
Yeah, so a raindrop that falls west of that goes all the way to the Pacific by rivers there, the Columbia River or it's the Rio Grande maybe.
there could be another one on the west coast. Like
Yeah, because we don't, there's no lines on this one
there might
showing it
be
go that way.
that
is the
it goes in
Missouri-
between on the
Missouri
valley,
River.
and then the rest goes.
this is the Ohio River. Maybe this.
Because I think the Sierra
It's the one on
Nevada,
the, all the way over there.
the Sierra Nevada has another one.
Corey. The Ohio River is the one that's furthest east.
You know what?
The little
Who
loop
knows?
is farthest east.
Yeah.
Is this Ohio or is this?
No.
I don't
No,
know.
the other one.
Ohio is closer to Pennsylvania.
Yeah,
Yeah,
That's what I thought.
up there.
she knew that.
Ohio is up there.
So another pattern is net or cracking. And this is the efficient use of space, efficient flow. You can have expansion and contraction with the net system. And it allows absorption of nutrients or other energies across the system. You can see the water can go into these cracks.
What are those? What are these things?
That's rock.
Ah.
What's the scale?
Hmm?
What's the scale? Is that
The
miles and
scale,
miles?
I don't
or-
know.
So kind of like how water
Is
will
it
go
another-
in through the cracks and then expand with the ice, and then kind of how it'll expand the rock itself, like as it freezes and then melts and freezes and then melts. Would that be like?
As water freezes and melts.
Right,
Yeah.
right,
Okay.
right, exactly.
Cool.
Yeah, and, again, as ground dries out, it will cause us net, and what advantage would there be to that? The water falls, it will absorb into the ground, right? So this is used in some older forms of architecture, and, this kind of architecture it's very strong. It's a mosque dome. It won't fall down in an earthquake. It's very strong structurally. This is another form of net pattern tessellation, and that's fitting shapes together. So this is a 6-sided. This is what tessellation is basically having the same kind of shape and fitting it in together. There's many forms that fit this tessellation pattern on, especially on a micro level. A lot of molecular and chemical forms will fit a tessellation pattern. So here's bubbles.
Wow.
This is a great example of that. These are pretty powerful forms when you get into how these work together. This is a 3D model of bubbles and how they foam, how it fits together. It has interesting properties. It's very expansive. It's structurally very strong. You can use a lot less material. So this is the Beijing National Aquatic Center. When they built this, the walls are much thinner, these are much thinner than they would have had to be otherwise, because this pattern is holding them in place very strongly. And so the light can come through both ways much more powerfully, and that's one reason they use that pattern.
Is it filled with water? Is it filled in with water?
No, it's got a pool, swimming pools and stuff in it. It's just,
But what is the wall made of?
I'm sorry?
Is it
What is
glass?
the wall made of? It's just glass?
Is
or-
it glass?
I'm not sure what the material is.
Plastic.
I think it's plastic. Do you know?
I don't know, but it looks like it would be plastic.
Yeah,
Bob is saying plastic.
yeah, I'm thinking that it's some kind of
It's laminated,
mixture
yeah.
of things. Okay, so we have spherical explosion, and this is again very, very common in nature. And you can use this in many different ways. This can be used, all of these can be used in an invisible structure as well as visible structure. The branching pattern is a very useful pattern in governance or in management of an area, of allowing people who are far away from a center to operate pretty independently, but to have some kind of connection to the central agency. That's one example. Net patterns are again extremely useful, very powerful. If you have a bunch of permaculture design demonstration sites and they connect up with each other and move out, you know, pretty soon everything will be permaculture, right?
Yes.
These are strategies. Invisible structure strategies can be done with patterns, using the patterns of nature. And circle is a very powerful invisible structure pattern from many different angles. You can spread energy quickly, like the dandelion, will just spread it. Some of these seed balls will actually, some seeds actually explode and release their seeds very broadly. This is a moringa seed. This attracts materials and particles. So you can actually use moringa seed as a filter for water. It will attract the pathogens to it. It's almost like a magnetic kind of effect. And then remove the seed and your water is 95 to 98% clear of particulates. Won't get it completely clear, but that could be enough to save lives.
What is this called?
Moringa.
Moringa seed.
How do you spell that?
We have some of those seeds, we'll distribute them to you. Moringa is a miracle plant.
Really?
Yeah. Let's talk a lot more about that.
So the seeds are still good then, you don't, when they absorb the pathogens, the seeds are still good though?
No, you
No.
crush
No,
the
because
seed.
you have to crush
They
it.
have to be crushed.
Okay,
Yeah.
thank you.
We have a couple planted.
Yes.
Oh, you do?
Defoliated in the cold
Moringa?
weather, but we have one in the garden.
Oh, good. I've had moringa.
So this is a great example of explosion sphere. Tremendous amount of energy in that particular model.
Now, what happens with the moringa after you crush it? Is
Yeah,
it
you-
waste at that point? You can't use it for anything?
Compost.
Compost.
You can plant it,
Yeah.
you can plant it. But usually we
You can
crush
put it in your
them.
compost
You-
because the rest of the things in the compost will
When you
clean
put
it.
them in the water, you crush them because you
Yeah.
want to get the most edge, so you can get the most particles. So usually you have to dispose of them in the compost pile where they'll cook, where the pathogens will cook. But you got it out of your water.
Or throw them in a biochar unit
There you go.
when you're done, yeah.
Okay. So here's some characteristics of circles, least amount of surface area for the most volume. So it's an efficient way to grow, retains energy well, it's got strength, there's equality. The radial, it's very efficient to send something out in all around you. You know, people think in linear terms, just in front of you. But think in terms of how to spread energy around in different patterns than just going straight ahead.
Reminds me of a labyrinth a little bit. It reminds me of a labyrinth a little bit. In a labyrinth, when you walk it, you are not going straight forward, but your focus is in the center.
Yeah, yeah. Okay, and this is very interesting, the circular pattern and the mandala, which is found in many, many cultures around the world. This is sand mandalas from the Navajo and from the Tibetan Buddhists. Very similar structures. They're the 4 directions and other elements that are really similar. And there's, you know, if you look at both cultures, these are more different than a lot of them. Some of the Navajos look really similar, and vice versa.
That's Buddhist.
Yeah.
That's Buddhist?
Tibetan Buddhist.
The Tibetan sand sculpture.
What was it about radial that you were saying?
I really like this artist.
I missed what you said about radial 2 slides ago. You said something, central government, I don't understand exactly what you mean by that.
You have a central government and it radiates outward to the rest of it. So Washington DC would radiate out different forms of energy and receive back different forms of energy you know, not just literally, but they happen to be on the right side of the country or the east side, but if they're in the center, then they would
Well,
send
the
out.
streets of DC are mapped exactly like that. So the Capitol is in the center. It's a circle, and all of the streets radiate out from
That's
the Capitol.
Wow.
Paris is like that too.
That's because
Detroit
Washington
is
was
like
designed
that,
by
too.
a French designer.
Oh, that makes sense.
That's interesting. Cool.
That's a fun fact.
The flower
There it
of
is.
life
There it is.
has a lot of information in it. This is one of the oldest symbols, again, found all over the world, India, Egypt, South America, different places. It's a very powerful pattern that's has similarities to molecular structures and cellular structures. People have a lot of opinions about it. There's not a lot of science about it, hard science, but it's something that's very ubiquitous and it's interesting.
Very cool monument in DC, by the way.
This is a form of, there's something called sacred geometry, where some people take the patterns of nature and because they've been found in spiritual practices throughout history, they connect those two things. And that's a very interesting subject. The spirals is another very common pattern. And there's a lot of, this is a broccoli.
Broccoli flower.
Romanesco broccoli.
Yeah, yeah. Yeah, this is also a lot of feelings about it. So efficient use of space, maximizing edge. So this is the permaculture rune. If you don't have one of these, then you're not really a permaculture. Signal from outer space. We'd walk in the yards in LA and there'd be one of these in the yard. We go, okay, permaculture designer. But they're not the best pattern for Florida because they tend to dry out sooner and they get too hot, especially if you're using rock.
If we can
That
find
doesn't
rock,
cool off. In a drylands, this can be great because you want it to be warmer at night. But
So
I'm an urbanite.
how can it be adapted for Florida?
well, you guys.
What's the
figure it out.
solution?
I'm just showing you the pattern.
What's the solution?
Marcia log.
Put a little
Bugs.
at the top or
We'll make one.
So it's very strong structurally, and it takes up a lot less space, and it's very aesthetic too. There's an aesthetics to spirals that are very powerful. Allows for regular growth. It uses very little energy to create the structure, and for instance, oh shoot, I don't have the shells in here. I have them later, but you guys have all seen snail shells.
The Nautilus.
The Nautilus.
They grow at a set rate, and that spiral shape actually allows them to continue to grow at that set rate, even though they're growing a bigger and bigger shell. So this is a common pattern in water and wind. there's a few patterns like this that exist in water and wind that you can use to your advantage for different things. Or it's good to know about them because when you're dealing with wind on a site and you're trying to block it, if you do it wrong, you're going to get more turbulence because of these kinds of patterns. So it's called an Overbeck jet, and you can see, trying to use this. There's an island here. Here's an island, and you can see it better here. And when the wind goes over this island, it actually creates these patterns in the clouds. So you can see how high this stuff goes. You know, you can imagine when wind hits trees, what happens with the clouds. And you can see how these patterns are formed. Rain patterns and different patterns can be formed by trees, by this illustration. That's one of the main reasons I have this up here, so you can very clearly see the effect created. And these are as a flag flaps in the wind. This is a Von Karman trail is an Overbeck jet that's repeated. And these guys, the guys who discovered them it gets named after them. So Von Karman figured out that Overbeck jets repeated, and Overbeck discovered this pattern.
Would that pattern change
You
in
have to
different?
remember these names. You can call them whatever you want, you know. What?
Would that change in any way in different hemispheres?
Does it change?
Would that pattern change in a different hemisphere? Is this, or is it the same no matter where you are? I mean,
The next one does. I don't know about this.
I don't know if it's spiral in a different direction
yes.
or what.
I don't know about this one. I can't answer that
In
question.
Australia, it's the other way
The
around.
next one that we're
When
going to
poles
do does.
switch.
Will you be going into more detail about how to plant or create windbreaks
Yes.
effectively?
Yes, we're getting to that. Okay, so Ekman spirals are similar to Von Karman trails. They're just a little bit, instead of being instead of going like this, they go, so they're separated out a little bit. And upward flow of air can reach 20 to 40 times the height of the trees. This can create rain bands under the right conditions. Now, this is something that Mollison asserts and isn't very accessible in the scientific literature, at least that I could find. And I've searched it pretty thoroughly. Doesn't mean it's not there, but I didn't find it. Mollison asserts a lot of things and that science hasn't proved yet. And so far, he hasn't been wrong very much, if at all.
So did Einstein.
I'm just letting you know, if you try to find this in the scientific literature, it might not be readily available. This the thing about Ekman spirals with trees, especially this part. So if you have a single tree, especially, this is a little bit misleading, but if you have a single tree, what happens is that wind gets compressed here, it comes over and creates a turbulence. And you can experience this for yourself very easily. Just stand on the lee side of a wall or a single line of trees and see if you feel the wind on the other side. The wind is coming this way and you're on this side of the trees or the wall, you will feel the wind. It'll come right into your yard and be spinning around.
You can actually feel it in the highway. If you're following a truck.
Yes, I was thinking the
If
same
it's a
thing.
single straight, so the single straight thing is actually not a very good windbreak. That's the point of this. Much better windbreak would be if you took this tree over here, this tree, and made a line. Have at least three, a bush, a tree, and a tree, and made a line, because then the wind will come up, instead of getting pressured here, and going over, it'll just come up right here. Some of it will also go through. So you want your windbreak to be porous. It actually works better if it's porous. If it's not, the wind gets a lot of pressure right here because there's no escape, and then it comes around and does that.
Would bamboo negate some of that effect because it bends more in the wind?
I'm sorry?
Would bamboo, if you had a single wind, like you're saying, single line of trees, if you had a single line of bamboo, do you think that would be a little more effective than a tree because it gives so much, or it's still gonna get that spiral over the top?
You'll still get it. The bamboo clumps though, and you need the line on the other side where the wind can actually be directed up and out.
What if you
Instead of
put,
hitting
if
something.
there was shrubbery maybe, or smaller bushes on that
Yeah.
side?
Yeah,
So because of the height of the
bamboo does
bamboo?
come out, it depends on how it is. If it's just straight and tall and it bushes up at the top, you're probably gonna get some turbulence. But it's really great to observe wind patterns on your own, because you learn a lot. You experience a wind tunnel. You really have to. I would strongly recommend that you just go on windy days and stand at different things and really observe what it's doing, so that you can feel and understand it from a feeling viewpoint. This is all intellectual and it's good information, but you really get it when you're when you're paying attention to what the wind is doing. And South Dakota is a great place to observe that. It blows all the time, and it blows really from every direction and really hard sometimes. So we've gotten to see a lot of stuff about what wind does up there. But if you have a beautiful windbreak, but you happen to place two trees, you happen to place a tree so there's a little tunnel, you're going to get just intense wind coming through that tunnel right into your garden areas. You really have to place your trees carefully to make the windbreak effective. And here, it's not so much an issue because we don't have that much wind. Up there, it's much more of an issue. You guys ever seen snow fences? Those orange fences with holes in them?
Yeah.
Well, they have holes for a reason. They need to let through some of that pressure. Because if they were just solid, it wouldn't work as well. Okay. So here's another practical application of Von Karman Trail. This is a keyhole garden bed. This is the path. This is the bed, and you could have the bed straight across and have little paths over here too. But you're going to have the least amount of path in this system and the most amount of growing space. So in a small area, especially, that's a really great way to do it.
That's what you have at your home, right?
Hmm?
That's what you have at your home.
Yeah, some modified version. But like if you had a really narrow section of your yard that you wanted to garden in, instead of doing it in rows, do it like this because you'll get a lot more growing space.
I have a question.
Hmm?
Back to the windbreak. For instance, like out in our garden there's some trees that over the cold period, they obviously really didn't like the cold wind, and the other ones behind some other, that was behind the chicken coop did fine. So how do you deal with, say we wanted to put a windbreak to protect those trees, but also we want a nice breeze for the chicken coop? How do you deal with those two things?
Leave a lot of holes. Use bushes and trees that aren't just really dense, that have holes, because you'll slow the wind down and then you'll have a breeze. That's what a windbreak will do. You don't want to totally block it.
Okay.
You just want to slow it down. So like sweet acacia is a tree with a lot of holes. Moringa, bushes with a lot of holes might be berry bushes instead of wax myrtle, for instance, which is very solid and dense. And we can look at it too, and might be able to answer your question better.
So this, you don't call those keyholes?
Huh?
You don't call them keyholes? I thought they were keyholes. what you
Keyhole
just
beds,
showed.
yeah,
Keyhole
these are
beds?
keyholes. So this is called a flow form, and these are amazing devices. These end up having spiral patterns where the water comes down through this, and it will it comes down and it will circle around this. It actually goes in order like this. It's really interesting to watch. This water comes in, circles around, goes over here, and same thing here. And what that does is it oxygenates the water tremendously. It creates so much life force in that water that you wouldn't normally get. And there's all different kinds of ways you can create these flow forms. But there's a lot of studying being done on flow forms and the molecular structure of water, and it changes. You can soften water by doing this. There's flow forms that you can put onto your water coming into your house where you can remove some of the hardness from it just by the pattern of the water going through the flow form. It's very amazing.
What's the name of it? What's the name of it?
Flow form. If you're going to have a waterfall, waterfalls are very oxygenating too, and that's why people like being around and they send off a lot of ions, negative ions, and make you feel better. These do as well, and they make, each one of these makes a different sound. It's very meditative. Here's some more examples. There's some people that are really getting into these. Hardly anyone sells these or manufactures them because they're not that well known yet. This is a wonderful opportunity for someone who likes to build stuff and wants to get into artistic things. I would buy them.
Yeah.
In my design business, I would buy from someone local that produces these. If there's anybody that I know of that's doing it.
There is an artist, I do not know her name or his name, I don't know. You know, if you go to Bok Tower Garden,
Huh?
Bok Tower Garden in
Actually has
Lake Wales.
that's right, in Lake Wales. They have not exactly like this, but somebody is making them out of the shell and coquina and sands, and then they have you can ask him to have different patterns. It's very organic looking and just flows. So.
Wow. Okay. Maybe
What's
we
the
can
name of
share
the
that with
place?
the whole group.
Bok Tower Garden.
Bok Tower Gardens. There in Florida.
Yeah, maybe we can email that to the whole group.
Do you have a preferred material for it to be made out of? I mean, do you want it to be poured concrete or out of stone? Or do you have a preferred material?
No, different things, different materials. I mean, obviously,
We want one that's doing multiple functions.
a more sustainable material would be preferred.
Yeah, you guys should go there.
A lot of them use
blooming
cement.
right now.
The manufacturers, most of these are some kind of cement.
Well,
This
they
is
used to
First of
organic.
all, those in
Center
the
middle.
How long it was, it was like 50 or 60 feet long. Going down.
Lake Wales.
Part of biofiltration for their big restaurants.
Beautiful place.
How do you spell it?
Like the northern part of Britain. Wales.
That
kind of Wales, yes.
Okay.
Right there.
I was like, oh, it doesn't look like Britain.
Yeah, it's cool.
I've been to Wales, have you ever been there?
These guys are real,
It's really impossible to understand.
they do some great stuff.
So
These
nice.
guys are in the UK, where I got this
Just
from.
jabbering really fast. Really nice.
Okay, so a lot of patterns are all about increasing edge. And sometimes you want to reduce edge depending on the design, but most of the time you want to increase it in some area or another of your design because you get more energy out of it. So fractals are all about increasing edge. Crenulating the edge. This is a crenulation pattern. I mean, you can't see it very well. It goes like this. This is basically a keyhole bed. You have fingers. You've seen, this is something urban planners are using now for neighborhoods to reduce the traffic flow in a residential neighborhood and to radiate out, so they'll have curvy streets and people don't drive down this. Can't really see that, huh? It's just some kind of random curve.
Yeah.
It's not a good picture.
The Dutch have been using that kind of a pattern in their small residential areas. They call it a woonerf, W-O-O-N-E-R-F, woonerf. And they have a place for parking cars, place to drive through, place for children to play. And because the whole thing, the edges come into this, if you're looking at it to try to drive through it, you would have to do like a slalom to get through it. But it interposes garden areas with parking areas, with play areas, and you can get from one side to the other, but it slows you way down.
Right.
And it gives a lot of interest and a lot of little nooks and crannies and a nice place for a fire pit. Woonerf, if you look on the web, you'll find really neat images of that. W-O-O-N-E-R-F, Woonerf. And this is a
Sort of
Dutch.
like a meander, right?
Yeah.
Yes.
You're
Yes.
slowing down the traffic and people have to look and be
Yeah.
part of this part of the community instead of going.
So it's usually kind of on the back side of housing, where maybe you have a straighter street on the front for the delivery man and so on. But when it comes for the people to come home at night and the children to play, and the kitchen door maybe opens into this, and the little gardens are there. Yeah, it's lots of, it's a
wonderful.
really nice
Sounds
set of
good.
pattern, yeah.
So very cool.
Yeah, very Dutch.
Yeah.
Things. Yeah.
Cool. So these are some water. You don't ever make a pond that's a circle. Unless you have a kiddie pool, and that's all you can do. Like I do in my backyard right now. It's free. It's by the side of the road. So. But I'm putting edge in it by putting some soil in here and creating some edge. So this is, you get a lot more nutrition and life forms in something that has more edge. You put a lot of stuff along the edge of the pond. Fish and a lot of things prefer the edge. The chinampas, we'll get into a lot later. They're one of the most efficient, effective ways of growing food on the planet. It was used by the Aztecs, and we'll go into detail about it. It's a great system for Florida, great system for flatlands and swampy. Okay. And then this stuff is kind of what we went over already. Okay, so the golden mean is an amazing mathematical formula, and it's found all over the world in very interesting places. It's really fascinating. And what it is this is a perfect square, 1 by 1. You start in the middle of the square, you do a radius, so this would be a circle, and get your second measurement, which is, this continues out. It's not an exact, but this ratio, this is how it was found in ancient times, most likely. They had a perfect square, and then they took a string and made a circle and found the second formula. Do you understand?
Yeah.
You stand in a spot and have a string and draw the radius like this, or the circumference, I'm sorry, the circle. So this is found all over, and it aligns with something else that's also found in nature called the Fibonacci sequence. And how many people know what a Fibonacci sequence is? Okay, a few of you. It's a mathematical formula. It starts 1. The second number is 1. So 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. On and on. And that formula is found all over in the natural world. Here's an example. The nautilus shell is in a Fibonacci sequence. And this is 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 8 by 8. Okay, 5 plus 8 is 13. 13 by 13. That's an example of the Fibonacci spiral, which is a spiral shape that's found a lot in nature. And it also, these are all golden means. So you have a square here, and then this is that second section. You see? So you have a square here, and this is the second section.
Oh,
Like
yeah.
like this.
Move on to that.
Like this. Right? See that?
Golden mean, perfect ratio.
So these are two mathematical formulas that are found all over the natural world, but also found all over ancient architecture. Like this, in all different parts of the world. There's the Greek Parthenon, you have the Taj Mahal, which has all kinds of golden mean. This is the square, this is the golden mean. So you have the square. But this is the Fibonacci sequence here, and the golden mean. And then you have a golden mean here as well. It's right here. It's a very pleasing aesthetic ratio that you find in a lot of photographs that are award-winning photographs will have this golden mean in them. And a lot of art as well. You find that ratio. It's not centered, it's off just that much. Here's the nautilus shell. This is stronger because of that ratio. the ratio actually adds strength. This is very interesting. This has a golden mean ratio. The leaves go around in a spiral in a golden mean. And what that does is it allows sunlight to hit every single leaf. So you can think about that in designing. If you have a vertical structure and you want to get maximum sunlight, then you can look at placing the plants at that ratio so that they get the maximum light.
Huh.
So the pyramid was built to maximize stability using the golden mean ratio. This says these shapes have golden mean and also Fibonacci sequence. This has Fibonacci sequence in it. And the petals of flowers are often related to the golden ratio. Is that incredible? So this, the flower petal versus this, different places on the flower have that ratio. Golden section is based on rhythms apparent to the eye and clear in their relations with one another. These rhythms are at the very root of human activities. They resound in man by an organic inevitability, the same fine inevitability which causes the tracing out of the golden section by children, old men, savages, and the learned. This is from Swiss architect Le Corbusier. So here's another Fibonacci sequence and golden ratio per hand. This is another one, Fibonacci sequence on cactus. There we go. And this is just another, we're out of the golden ratio now, going into macro, micro patterns all over the universe. This is a branching pattern that's found in a brain cell and in how the universe is formed. And the last pattern that we're going to cover is the general model, which is a permaculture central pattern. This has many of the patterns in it, and this is a tree pattern. It's a pattern of energy exchange, which is very powerful. So you have the roots, the leaves, and really efficient energy exchange going through the trunk and being distributed in both directions. So
that would make an amazing structure for growing beans on. That would be great for growing beans on.
Yeah. So you can think in terms of design. We'll do some practicing with this stuff. You can think in terms of how you can incorporate these into the designs. And we'll do some stuff that will help you do that. There's Taurus, similar to the ancient symbols. So it's pretty interesting to see how much of our symbology is related to actual, really basic patterns in the physical universe. So I was going to take you through really quickly. We're going to break in a few minutes, but I wanted to just take you through and have you name out the patterns. This is a journey exercise. Okay. So that's Escalante in Utah. Have anyone seen that? It's gorgeous. It's formed by water running through it. So what is that pattern?
Taurus. Taurus.
Branching.
Okay.
Streamlines and meanders.
Yeah. Yeah.
Streamlines and meanders, not Taurus.
That goes.
That's the
Spiral.
Branch.
Branches. Okay.
Spiral.
That's an
It's
escarole.
a Rex Begonia.
I heard it called an escarole begonia. Escarole begonia, like snail
Because
begonia.
it does look like a snail a little bit, I can see that.
Yeah, it's edible too.
Branching.
Peacock.
Tessellation. Tessellation.
And what role does this play, how does it help this creature to have that pattern?
Protect,
attract
a mate.
Yeah. What else?
Maybe evade predators?
What's the function of the pattern?
Well, it's working with the natural edges of the feather, and so by having a different color at the edge.
Light reflection?
You can, I mean, it's working with an existing shape, because the ones up close are more like thread filament-like, and the ones out there are getting to be more like functional feathers for flying and doing bird things.
Insulation.
Okay. Also, what would they do in rain?
Shed the water away from the filaments.
How about wind?
What would they do in that rain?
Depends on how that bird positions itself.
Windbreak?
So could the bird could position itself though to protect itself?
Ooh, that's beautiful, branching.
Okay, that's also
So
a
easy.
general,
It's the easiest one.
general model too, right?
Yeah. Wow. That's gorgeous.
Where is that?
Is that fractal? What is that?
Yeah, really, is that grease or is that an iceberg, or what do we got here? What is that a picture of, is that?
It's ice, oops.
Looks like
It's ice,
What's the pattern?
ice cave.
Is that the overback for the?
What is the pattern there? What's the pattern?
What's the pattern? Overback jet?
Meander?
Meander.
Okay, meander.
What about in the rock?
That's what I was looking at.
Water, a lot of times creates meander patterns. How about that?
Explosion.
Central explosion.
Sphere?
So think of what happens with that mushroom. What does it do?
It pokes through something that opens once it pierces.
Okay. So it's a, the top part of it is a spherical explosion.
Oh.
Net or
Emphasize the
cracking?
central.
And the-
Net?
Hmm?
Is it a net?
There's a general model aspect.
Oh, okay.
Yeah, for the trunk.
Underneath would be radial branching.
Yeah, yeah. I mean, a lot of times you'll get this
Looks like it
burst
grew
of
really
energy coming
fast.
out like this in a general model.
Branch.
Oh, that's
Yeah.
fractal.
What
Is
else?
that mandala?
Fractal?
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 Or
Uh-huh.
mandala?
What else?
Mandala? Mandala?
Net or cracking?
One more.
Radial?
Huh?
Radial?
Yeah.
A little bit like keyhole also.
Huh?
Yeah.
Ah.
Spherical explosion.
Yeah. Uh-uh.
So you got that there, toss it in the ants lace.
Yeah.
Circles and radial parties.
So there's a fractal.
It's either fennel or Queen Anne's lace.
Queen Anne.
What is the flower?
I don't know. Oh, that's a,
Is that Queen Anne's lace? Yeah.
Are you considering the spherical, the circles and the radial part of the spherical explosion pattern?
radio
In
spherical
circles.
explosion, yeah. Okay.
Branching.
That one.
Branching.
So are you perceiving what the energy is doing in this? What is it doing? Yeah. And the leaves actually pick up nutrition from the air, which they send out as well.
Branching?
Yeah. So what does this do? What's the function of this? Why is it shaped like that?
To catch more water.
Collects water, catch
Yeah.
sunlight.
Oh.
Avatar.
Yeah. So what's the function of this?
Catch
You
more
touch it,
water.
Make the water drip on the roots.
Yeah, water's centered.
Yeah. Yeah.
A good fan.
That's true as well. Ground, so the water doesn't evaporate.
Slide for box.
equal bunch of
Yeah, shade. Mm-hmm.
just like the Fibonacci sequence in the other plant. I mean, it's got like the equal kind of how it's set out in the spiral as well.
It's probably a gold ratio, I can't tell for sure, but
The
it's.
circles in the radio.
On Pandora,
Is it
they have a flower that spins around and floats down in that pattern.
Nice place for vacation. One is called chaos, yeah.
What is that?
How does it go? Who can sing it?
Music.
Yeah, I know that, but I mean, the hell is that? Two different pieces on top of each other.
Well, it's two clefs, there's a treble and a bass clef.
That's a test.
That's the keyhole type, you know, passage in the middle and something else.
Can you play that on your violin?
No. Yeah, that's just for fun. I couldn't resist right now. These are keyline designs, and keyline is a form of plowing that allows water to seep into a landscape and revitalizes the landscape. And we'll go into that in more detail, but it's, you know, it's on a contour of the land. They're cut on to the contours so that this whole line is even all the way around.
Carnivores. How am I doing?
Well, a path basically branches because you have your government, your A animal, and the rest branch from there.
I could, just expanding on like the spherical explosion, they talked about like the central government and stuff.
Government, it fits government.
You think about how wolves operate, what kind of patterns do they use to operate? Do you get, you know, when they hunt or when they?
Pack.
Cooperation.
Yeah. Do you guys know how they hunt?
In
They'll
circles.
kind of
They
circle around
surround,
and
yeah.
herd animals and then pick out the one that's weak
The
or slow.
weakest.
So it's kind of like a circular implosion.
They ambush.
They're directing the energy.
General model.
It's pretty cool, huh?
That's very
Target.
Patterning.
Cracking
They
and
really talked about this a bit.
Butterflies.
tessellation. Beautiful.
It's good. So what's the purpose of using that pattern with these guys? What is it? How does it serve them?
Strength. Helps to support them on the trees. Like when they're hanging from the trees in Mexico, it creates strength, so that way they can kind of like interlace.
It creates a stronger structure.
Probably to do making a windbreak for each other's feet, and then maybe also for sheltering from the elements now. I mean, they're kind of overlapping each other just like the birds' feathers would do. So I imagine they probably position themselves strategically, depending, I mean, just through observation, whatever you're comparing to birds' feathers, I mean, they're kind of making overlap, but have to look at it closer.
You also give more of them in the small space too, right? There might be a reason for that.
Especially since they
You
all
don't see the whole context.
pop.
Safety in numbers.
Yeah, they look like one big thing. Something may not go after them.
Also helps them adapt their technique.
Wow. And the goats were.
An artist did that.
Andy Goldsworthy's
That's how it looked like.
Koreen, is that Andy Goldsworthy's work?
I didn't write it down. I should have, but
Seems like
it's pretty cool. It's tapping into some kind of pattern there.
There you go.
Spiral.
The spiral.
So what are these spirals doing?
Concentrating.
Focusing in the center.
The top one's getting more sun, right, by the formation there? All the
Golden
leaves, golden mean, all the leaves are able to get the sun on the top of it. And the snail,
This, you know, the hurricane is a very solid mass. It will stay that way for a long time on water until it hits land, until it hits trees and buildings, and that breaks it up. Very stable shape.
wow.
There's a
So
fish,
what
right?
pattern are these fish using?
Shark survival.
They're swimming around in a circle around the shark, which is weird because it's, I would expect it the other way. That's interesting.
Well, I think they're trying to get away.
Are they separating
They're going
the-
toward.
Are
would
they?
explode.
Oh, yeah, they look like they're swimming toward the shark.
Because they're eating
It's
this.
very Rambo.
They're swimming toward the shark's tail. They're swimming away from the shark's mouth.
It's a good explosion, right?
Oh, that makes more sense.
They have a lot of meandering going on in there. Ooh.
Oh, that's cool.
Where is that?
This is one of the most sustainable forms of agriculture on the planet.
China?
China and Philippines and some other places that have the tall the mountains.
Indonesia.
Why is it the most
Tremendous amount of
sustainable?
production in that system, and they use the water very wisely. It's called Terra Aquaculture. Terra Aquaculture. Earth, water, culture. And a very cooperative system too. This whole mountainside, every farmer on there has to cooperate to make sure all the farmers get enough water. If there's a drought, they have to cooperate and decide where they're gonna send the water. That exercise alone is very admirable. And they're using, you know, they get a lot of extra stuff stuck in there to make sure the village has enough water. It's just been done that way for many, actually thousands of years. The system is thousands of years old.
How do you call the pattern here? What is the name
What
of
kind
the
of pattern
pattern?
is that?
Yeah.
What do you think?
Yeah.
I'm blank.
Nobody else.
I meander on
Some
top of
meandering.
it.
Yeah.
Meander and what?
No.
Meandering?
You're following the contour of the land. These are all cut on contour to work with the land.
Does everybody understand what a contour is? When you have elevation, think about the sea level rising. Every point that you had another 1 foot of sea level rise, that would be a 1 foot contour. The sea level rises 1 more foot, draw a line around where that water goes. That's the next contour. So it's a level, it's a way of leveling. If you have one contour, water will fill it to the same depth. Each one of those will have water in it to the same depth.
These walls are all level. They were cut onto, the land is all level right along these walls. So that's why the odd shape, because the land is level in different places. You have to follow. We're actually going to practice this so you can see.
Okay.
So that's sand magnified.
Wow.
It's beautiful. That's the president's version of it.
Wow.
Oh, I want some.
Yeah.
It's everywhere.
I never expected sand looked like that.
Yeah. Gave me more affinity for Florida sand. You see there's a lot of shapes, a lot of patterns.
Yeah, these are the things you see, you know, larger.
Mhm.
You don't think about the fact that when the sand is so tiny, it still retains that integrity. That's amazing.
So that's a mandala garden, right? Which they have. And that we already went over. This is some architectural patterns. You see a lot of these are older forms. You can see when you see older architecture, you'll see so many natural patterns in it. This is, we didn't really talk about this. This is an arch pattern, and it's very strong.
Literally dirt.
This is sandbag, earth bag housing. and very amazing type of architecture, natural.
They're-
These are rice bags, and they're filled with earth, and the house looks like that when it's done.
Wow.
Wow. Very nice.
So basically they
One's
just put
very
the
energy
plaster
efficient.
on that and then
These are two different houses,
Oh,
two different
beautiful.
shots. This is obviously a, different kind of archway. You can do it rounded or heaped. It's a very strong form of architecture.
So you can use bags or you can use stone, it's the same.
Use what?
Stones, like cathedrals are made with
That's right.
stone, it's the same thing.
Yeah, those are the kind of
On
arches
this
cathedrals
principle.
use.
So I'm actually gonna take a break. It's time for lunch.
Yay.
Alright.
So thank you guys. We'll come back
Thank you.
to lunch. Thank you for lunch. Have you
You,
ever heard
you
of
could,
herbs
you could
yet?
use rice, you could use beans, you could use anything.
Well, the guys spread down the front. So we're gonna use.
So you would need something to conserve it.